Okay, it's pretty obvious from the tests we saw that this here 50 millimeter on a 6-inch aluminum plate that's 1/8 inch thick is going to be the best for detecting water leaks through a concrete slab around a pool. Welcome to the Stutzman 52 channel. So what we're talking about is a ground microphone that's going to be placed on a concrete slab looking for water leaks that's around a pool. Okay, so here we go. Let's take a look at what we got here. We have 3 different diameter piezo diaphragm crystals. We got a 35 millimeter, 41 millimeter, 50 millimeter. We got a 6-inch aluminum plate, 8-inch, and a 10-inch. Now the question is, which combination of these here piezos on which of these here is going to work the best? Now as we found out that the 50 millimeter on the 6-inch plate works the best. And the reason we're going to do this is because I needed to know which one of these here diameter plates with the different diameters on the crystals is going to be the most responsive to listen to frequencies from 70 to 850 hertz, which is typical of where you'll have these PVC leaks, water leaks underground, under a concrete slab. So, let me show you the test procedure and how we did that. Okay, so we already know that the 50 millimeter crystal on a 6-inch plate is going to be the most responsive. So let me show you how I had to do this here. Now, of course, I got 9 different combinations. I've done all the tests. So you can see I got crosshairs. I'm marking the center of the plate. So I'm just going to center it and right at the quadrant of each one of these. I'm just going to take a little bit of Scotch removable putty, and I'm just going to put it right here on each one of these here quadrants. And then we're going to take this and we're going to take it over to our test bench, and then we're going to show you what we did as far as in the testing of it. Okay, as you can see, I built a little stand. It has a 3-inch speaker. It is 1/2 inch above this here crystal. As you saw, the crystal is placed on the center of the plate. And this here is being driven by a LM386 audio circuit. And this is going to be putting out a frequency to the speaker, which is going to vibrate the piezo. And I'm looking at how much of an amplitude is coming off of that piezo. You can see I have a trace that's on here that's going to be looking at that. We come back over to the scope. So you can see I have one that's going to be for the output coming off of the driver, going to the speaker. And also the other trace is going to be looking at the piezo. So I'm going to be varying frequencies from 10 hertz, then I'll do 50, then I'll do 100, 150, 200, 250 on up to 1 kilohertz. And I'm going to be recording each one of these values. Now I'm not going to go through every one of these frequencies because it just takes too long, but I'm going to show you show you what we did. We capture it and then record it, and then we're going to do this. Of course, I did this for all 9 different combinations, and as you know, the 50 millimeter crystal on a 6-inch plate was the most responsive. Let's take a look at our signal generator here. Now let's assume that I went from 10, I went to 50, I went to 100, 150, 200, and then I got up to 300. And then I set the amplitude to 135 millivolts peak to peak. This is the signal that's going to go into the input of the LM386. Alright, so let's go ahead and we'll turn it on. Now we're going to take a look over at the scope. Okay, as you can see, the yellow trace is going to be the output of the LM386. That's going to be driving the speaker. And the purple is going to be the looking right across the piezo crystal. This is showing us how responsive it is to this particular frequency of 300 hertz. Now, it may be hard to read, but the measurements are on the bottom. For example, the yellow trace is 2.94 volts peak to peak. Frequency shown is the 300 hertz that we're injecting into the input of the LM386. Also, we're looking at the peak to peak voltage of the crystal. In this particular case, it's around about 48 millivolts peak to peak. And as far as the frequency, we're showing the frequency of the crystal, which is also at 300 hertz. Now the readings are bouncing around just a little bit, so I'm going to press the single button one time, and what that'll do is it'll freeze that display, and then we can come back and we can write these measurements down because now they're stable. Now also from the signal generator, we can set it up as sweep frequencies. For right now, I got it set for 10 seconds. It'll start a frequency of 10 hertz, go up to 10 kilohertz, and just so you can see what that'll look like. Now here we're looking at a Bode plot that the scope is generating. So we're looking at the red trace is the amplitude, the green trace is going to be the phase, and of course we're looking at this here same 50 millimeter diameter crystal on a 6-inch plate. We want to see how it responds to different frequencies. You notice that the red trace is climbing pretty high, around about 70 hertz right now, I think, you're looking at it. So it's really getting up there. So with our frequencies from 70 to 850, we're going to see that it's going to respond pretty good. Okay, so we'll just let that continue. See what she looks like. As I mentioned, we're going from 10 hertz to 10 kilohertz. We're injecting a signal of 135 millivolts peak to peak. Now, you realize I'm doing this on a wooden table, so this is it's not like concrete and even we got dirt underneath. This is a comparative test. This should be still valid over a concrete slab, which I expect that our signal should be even higher. So like I said, it's just a comparative test, but it should be still a valid test. Now you notice where it peaks right up there? If you look at the red trace, that looks around about 300 hertz. That's the resonant frequency of the speaker. And if you look over to the a little bit further on, you can see that we have another frequency that peaked out, and that looks around about, it's hard to see from my angle, but I'm thinking it looks around close to 3,000 hertz. So it's supposed to, resonant frequency of this here crystal is supposed to be around 3,200 hertz. Now here's the data for the 50 millimeter piezo crystal on a 6-inch diameter plate. Basically, you can see here's the input frequency that was injected. Here's the peak voltage from the LM386 driving the speaker. Over here is the millivolts that's on the piezo. Over here, this is the frequency that was shown to be across the piezo. And over here is a calculation of the voltage gain from the LM386. Hope you enjoyed the video. We'll see you guys in the next one.